Hey guys, welcome to Great Learning. Machine learning is considered to be one of the most impactful technologies we have today. It sees its large usage in almost all the domains we have, and it is equally popular among students, researchers, and professionals. I am sure you already know that a well-tuned machine learning model is very powerful and efficient at solving problems. This is only because the data that is fed into the algorithms and eventually the result we get out of it, right? Since this is a foundational concept, it is super important that all of you all have a clear understanding of these algorithms. Here, we will ensure to take a look at understanding supervised learning, unsupervised learning, and even reinforcement learning theoretically and practically as well. An ample amount of practical demonstration in Python is provided to help concrete your understanding on the same. With that, I know you guys are super excited to get started with this. What are we waiting for? My name is Anirudh Rao. Let's get started.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, coming to the agenda on this machine learning algorithms video, basically what you will be looking at is to understanding everything right from understanding what machine learning is, taking an introduction to it, why it is required, where it is used, to looking at the machine learning process, as in how machine learning actually works. Once you understand how it works, once you know it's the reason for its popularity and the reason for its working, you'll be very curious to later understand, okay, so if this is how algorithms work, what are the various types of learning that your machine learning algorithm can go on to do, right? That's where we'll take a look at the types of machine learning algorithms. We're going to be discussing all of them to a good amount of detail with a lot of theoretical discussions and practical hands-on. And of course, as soon as we go on to finish the theoretical discussions of these algorithms, we are going to be heading right into Python and checking each of them out practically as well, right? So I hope you guys are excited about all the points of the agenda. With that, without further ado, let's go. Machine learning is one of these concepts which form to be the most important aspect of data science that there is. When you think about how you can get to artificial intelligence, right? Artificial intelligence and data science go hand in hand because AI is the biggest application of data science there is. But to get from data science to AI, you require machine learning in the middle. That is why it is the most important stepping stone that adds so much value, right? So what are we doing with machine learning? With machine learning, the goal is very simple. So we make sure that, we get the machines to understand data on its own, to learn on its own, and eventually give us a solution without us having to intervene during this entire process. Now, it is very, very easy to say that, hey, machines are very intelligent. They understand a lot of things. But as I've been mentioning in the previous modules, your machine can only understand zeros and ones at its most functional level. Everything apart from that is just added for our convenience of how we can communicate with the machine better, right? So if you show a picture of a cat or a dog to your machine, there is a very good chance it will not understand anything unless it is trained or unless it is told that, hey, what you're seeing is a picture of a cat, what you're seeing is a picture of a dog, right? So what is the goal if it is naive at this level? Well, the goal is to make sure that our task in many cases can be simplified to its most easiest way possible by getting the machine to do work for us, right? So making the machine think like us, making the machine think like human beings is the primary goal here. Now, again, if you've been wondering about where the machine learning data comes from, where it learns, again, there are numerous data sets to, singleton problems, customized problems. There's so many ways where you can collect data, as I've been already telling you since module number 1. You can collect data from multiple places and then have work on it, right? So here in the case of machine learning as well, the same thing applies. Data comes from a variety of places, it gets stored, and eventually then, a solution is derived based upon the data at hand, and after it goes through an algorithm and all of that. So the first question you really should ask yourself is, why is machine learning required in the first place? Why is it, the biggest thing in today's world, right? First of all, you have to understand that there's hundreds and hundreds of reasons. We can have a discussion hours together just talking about the advantages of machine learning. But to give you a clear and a concise picture of what, you can expect, well, here are some of the important pointers. First of all, the most important thing is that it will help reduce production cost to a very, very big extent, right? Now, it is not only just production cost, it is everything right from production till delivery of of a product to the customer, right? Machine learning can sit in all of these different phases of product manufacturing and delivery in a way where you thought it was not possible before, right? From material procurement, right from actually processing it, quality control to delivery, supply chain analysis. You can do everything when it comes to production here. The next reason why it became really popular is that you already know we generate a huge amount of data every day, right? With machine learning, the advantage here is that you can process all of these very, very easily, very in a simple fashion where you do not have to break your head to go through a lot of data, right? That's the advantage. The next thing is individuals, startups, multinational corporation, whoever you are at the end of the day, you can derive some key insights about your business in a very clear and a concise way if you go on to make use of machine learning. It simplifies your tasks not only in a way where it tells you that you've gone wrong here based on the past data, but it can also use past data and present data and give you a forecast into the future. It can tell you, hey, down the line, your company can sell these many products. It is forecasted that you can sell all of these products. So imagine, probably a couple of years before, maybe 20, 30 years before, if someone told you can use your computer to predict the future, they would still treat it as a joke, right? Now it's not so much of a joke. Data is the new oil. It is packed. It's a treasure. You can use it to derive all of these insights. And it's a beautiful thing to do it as well. Again, we're going to see all of these practically in this module. The fourth point is what I just mentioned, right? You can find out hidden trends that are present in data. Now, let's say data, think of data as maybe a bowl of rice, right? If you just look at a bowl of rice, you really cannot make any sense out of it. But let's say that there is little snippets of gold hidden inside this bowl of rice. So if you put your hand, dump in, if you churn through the rice, and if you put in your hand, do the hard work, and then you can pick up these tiny figments of gold which was not visible to the naked eye, right? This is exactly how data is. It's like playing treasure hunt with the data. You will know that there is something at the end of the tunnel, but to get to that, you have to work. That work takes extreme amount of processing, and that is why we require machine learning. So I hope I was clear with why you guys should definitely look at learning machine learning, right? Now, the next thing after you understand why machine learning is that you have to look at the different types of machine learning. Because if you do not understand the fundamental concept of how machine learning is divided, it becomes very difficult later down the line. So guys, there are three different types of machine learning of, how a machine itself learns in this domain. It is supervised learning, it is unsupervised learning, and it is reinforcement learning. Now, these three learning methodologies, right, they work in very, very, very different ways. Each has its own application, each has further subdivisions and a lot of things, but these are extremely important. These are foundational for everything. Make sure you're putting an ample amount of concentration for these slides, guys. Right. The first one that we are going to check out is supervised learning. Now, think away from data science, think away from machine learning for a second here. When someone says supervised learning, or that you're learning with some supervision, what's the first thing that comes into your mind? Because for me, it's probably a child who is studying for an examination, and there's a parent who is supervising and making sure that, the child is not playing games, but is actually studying. Supervision, right? Keeping a control. Now, in the case of machine learning, things work similarly to the analogy that I just mentioned to you. Here, however, it is not the machine itself governing. It is the data which is governing. It is the governing entity in a way where the machine itself knows what data it is seeing. It is not literally being supervised, but it understands the data as if it were supervised. That's the difference here, guys. So you have three images on your screen right now. Let me use those examples to explain supervised learning for you. You have the image of a flower, you have some dumbbells, and you have a car here. Now, you as a human being is probably taught from a very young age to see not one, not 100, but 1,000 pictures of flowers to say it's a flower, right? You will not see a flower and call it an aeroplane. You know that is wrong. You have been trained over the years again and again and again. You see a picture of a dumbbell, right? There's a good chance it can be slightly confusing because you might have never used a dumbbell, or if you have, it is very easy to spot it, right? Now car is definitely a popular thing that you've seen, you've known. You would have seen thousands of cars in your lifetime, hundreds of colors, hundreds of models, all of these. So as soon as you look at the picture that I've put in here, there's a good chance that you can say, hey, it's an orange color, it's this brand, it's a coupe, it has this brand sport wheels, it comes with this engine. You can actually go on to tell the model just by looking at that image. But if you show the image to a computer, no, it will not understand any of these, right? You have to be very clear about that. So to bridge this gap of us telling the machine what it is seeing, right, the advantage of supervised learning is we give the labels for the data. If the data is the image of a flower, we give a label. We tell, hey computer, here is the image of a flower. We specifically mention that it's a flower and then give the image to the machine learning algorithm. So at the end of the day, the machine learning algorithm already knows what it is seeing. So it uses that to learn and later predict other images which might be of the case. Now, this is just one example of supervised learning that I'm giving to you. But having these labels below that says this is a car, this is a dumbbell, this is a flower, right? That is very important for supervised learning. Now, with unsupervised learning, you don't do this. I'm going to explain that in a second. But before that, here's another important concept that you definitely should know about when it comes to supervised learning. See, supervised learning is a very simple form of how we can have an input. How can we apply a function on the input to eventually transform and arrive at a solution, right? So if your input variable, as we call it, is considered as x, applying a function on it becomes f of x. If you assign this to another variable, y is equal to f of x is what we get. This is the foundation of supervised learning. We are trying to map the output as a function of the input, right? So we have the input, you're doing some transformation on the input, which eventually takes you to the output, right? So whenever there is a common discussion, y is equal to f of x, now you know what y is equal to f of x means. You have an input, you apply a transformation, you apply functions on it, you do a lot of things to the input to take it from its raw form to a processed form, and the process form itself is considered as y, which is the output variable in this particular case, guys. So this is a very, very important thing about supervised learning that you should know about. But then, did you know that supervised learning is further branched into two things called as regression and classification? Now, first of all, machine learning is divided into three things: supervised learning, unsupervised learning, and reinforcement learning, right? Now, supervised learning branches into two, where it's called as regression on one side, classification on the other. Now, if you've been wondering about what regression means, again, regression is a concept which I have already discussed previously, where you take in data from the past and you try to predict what might happen in the future. Or let's say you take data from the past and you understand why we are at this point in time today, right? We're going to be discussing a regression use case practically as well. So make sure you stick around till the end of this module. So regression is a very simple concept. Again, we're going to discuss it with an example. But if you're looking at classification, right? Classification is a simple concept which you've already used. Regression is something which you might have used in a casual conversation, but classification is something which you know you have done. Let me give you an example. If I give you, a ripe apple versus an unripe apple, or let's say I give you 3 apples or 2 oranges, I mix it and I give it to you. I say, hey, based on the shape of the apple, based on the shape of the fruit, why don't you split it out and classify it differently? Well, an orange is a round fruit, right? So you just take it and you move it to another place. On the left, you keep an apple. The apple has a very unique shape, right? So you put it on the left. Now, if I said, hey, why don't you classify it now based on the type of fruit? Now, there might be a case where there's a defect in the apple and it is now round, right? There are certain chances that it is almost round, you can get confused. But if I say, classified based on the fruit only, you will know no matter what size or shape the apple is, push it to the left. No matter what size or shape the orange is, push it to the right. That is a simple way of classification here. Now, let us take a look at supervised learning. Unsupervised learning is one of these types of learning which is a direct contrast to supervised learning. Here, the entire goal of the machine learning algorithm is not us telling what the data is, but it figuring it out on its own. So the entire usage of unsupervised learning is based upon how the machine learning algorithm itself can find some sort of hidden structure or pattern that is present in the data without us specifically telling it, right? Now, take a look at the same three images I have on your screen. Flowers, dumbbell, and car. But this time I have not labeled it, right? That is done on purpose because here in unsupervised learning, you do not label the data. You just give it an input variable and let the machine learning algorithm figure out on its own. Now, there is a very, very good chance that now there's a question in your mind saying, okay, so if you're not helping the machine, is unsupervised learning a complex procedure compared to supervised learning? In many cases, the answer is yes, because here, it is not just cross-referencing what it has learned to what it already knows, but here it has to first of all learn in a very different way and then work on cross-referencing. So it definitely takes a good amount of computing time, computing power, and of course, the way the machine learns, the way it uses algorithms to already know that it only has the input to get to the output and find a structure is very, very different compared to supervised learning. So I hope I was clear in that point, right? Now, if you're looking at grouping, another very important thing that you have to know in unsupervised learning is that there's two groupings just like how we had for supervised learning. But here, instead of regression and classification like how we had in supervised learning, in unsupervised learning, we have clustering and association. Now, clustering is a fantastic example which again you would have used in your real life anyway. If I give you 3 erasers, 2 pencils and 5 pens and say, can you group all of these things separately and keep it into 2 or 3 piles? Can you or can you not do it? You can do it in a very simple way because you know what a pen looks like, you know what an eraser looks like, you know what a pencil looks like, and you know how to club it and group it and keep it separately, right? Does the machine know this? No. But if you train it, can it understand this? Absolutely yes. That is the entire point of using unsupervised learning, right? So that is a simple example of clustering. Now let us take a look at a simple example of association. Again, association is something which you have used, but you might not know you've used. Maybe you're on the Amazon's website. Maybe you're buying your favorite thing. Maybe you just bought a new mobile phone. Now, as soon as you buy a new mobile phone, as soon as you add it to the cart, there's an option below which says people who have bought this mobile phone also bought this. It may be a screen guard, it may be a case, it may be an earphone, whatever accessory, right? So it is recommending something to you. It is saying, hey, people bought this. No, people who bought this also bought this. So it is trying to map something. People who buy this phone have a good chance of buying the protective case for it, tempered glass for it, all of these things, right? That is association. Here's another example. Every time you finish watching a TV show on maybe Netflix or Amazon Prime, at the end of it, there is a good chance it recommends a very similar TV show for you. Now, if you watched a horror movie, the next recommendation is going to be a horror movie or a thriller or something like that. If you watched a comedy, a situational comedy, sitcom or anything like that, after you finish an episode or after you finish the TV show itself, the next one it's going to recommend to you is something similar because here, Amazon, Netflix and all, they're trying to understand what your preferences are, what you like watching, and eventually customizing their platform so your viewing experience is amazing, right? That is association. If you've been wondering, association is used not only in these 2-3 cases, but almost everywhere that you can think of. Everywhere where there's customization, where there is a goal to make sure that customer retention is high, will use association and even in fact a concept of clustering very popularly as well. So it becomes very, very vital that you understand that unsupervised learning is among the most popular algorithms or the types of learning there are in today's world. Right. Now that we checked out supervised learning and unsupervised learning, let's get to the third type of machine learning. Here we're going to take a look at reinforcement learning. Now, reinforcement learning is a very, very fun algorithm because again, here's an analogy in real life to simplify what it means. Okay, so how many of you guys have either pet cats or pet dogs at home? It works better with dogs and less with cats because I personally am a owner of both. So I know that it just works amazingly well with dogs. Right, here's the example. Have you ever had your dog trained professionally? Right now, a simple training, it usually starts out with sit, stand, give me a handshake, all of those instructions to your dog, right? Now, your dog does this. Your dog is trained in a way where if it gives a handshake, it gets a tiny reward. It gets a biscuit. It gets a treat, right? So your intention here is to get the dog to give you a handshake. The dog's intention is to train itself in a way where if it gives a handshake, it gets a treat. It gets a nice thing to eat, right? Your happiness lies in getting the handshake. The dog's happiness lies in getting the biscuit. It's two different things. But at the end of the day, your purpose of getting a handshake is being solved, right? So that's the thing. With cats, I've seen that if you ask a cat for a handshake, they just meow and run away and they don't care absolutely. Or I don't know, just is it my cats or something like that? But that's the most common thing that I have seen, right? So there's a reward which is waiting at the end of learning. Now, if the dog does not give a handshake and if you say, hey, give me a handshake and you extend, you try, but it runs away, it is not getting the treat. It is missing a treat. It is intelligent enough to understand that it has to work towards something, be it a handshake, be it sit, stand, roll over, whatever it is, to get that treat while it is being trained, right? Exactly the same thing here in machine learning as well. When a machine learning algorithm learns, here we are trying to make sure that it is learning based on its own feedback. It will use its feedback in a way where either it has to work towards the rewards. In case, if it is learning right, it will be given a reward every position of the way. If it is going away from the solution, if it is doing something which does not add value to the solution, it is punished or it is penalized. Of course, guys, this is just an example with machine learning. There is no penalization or there's no punishment with real pet dogs. It was just an analogy, so that's an important thing you have to note, right? In machine learning algorithm, the penalty or the reward is just mathematical numbers. It's +1, -1, all of these things which will eventually not hurt anything, right? So keep it at that. What happens here is exactly that. If it's going towards the goal, it is given a quick reward and it knows that it has to maximize the number of rewards it gets. If it is learning something which is not useful to the reward, it gets to the goal, it gets penalized and the rewards keep coming down. So the goal is to maximize the number of rewards, and it does this by looking at its previous steps, previous learnings, previous iterations. So that is how reinforcement learning works. It's a really, really fun way to work with machine learning. I absolutely love working with reinforcement learning. But again, in the most simplest way, it is okay to implement for a simple solution. But if you have very, very complex solutions where you have to use reinforcement learning, the implementation does become tough, guys. So that's one thing you should know about. Right. So next up, we're going to check out how a machine learning model actually goes on to learn. What is the procedure that a machine learning model uses to learn, right? Now, guys, you see a term that I'm using here, machine learning model. It is very different from a machine learning algorithm. See, once you have the data, you create an algorithm. You use this algorithm along with the data to get your result, right? But after it has seen the data, after it has learned and trained, it is no longer called as a machine learning algorithm. It is called as a machine learning model. So whenever someone says model training, model has trained, they never say algorithm has trained. Algorithm will be used for training. That's it. So after something gets trained, it is called as model, guys. Make sure you keep this in mind. Right. So how does a machine learning model learn? First of all, for a machine learning model to learn, it requires data, right? Again, I'm going to give you a real life analogy here, but let us talk about machine learning aspect first. You have certain data, one chunk of data that which you're going to use for this particular solution. You're going to split it into two actually. One batch is called as the training data. The other batch is called as the testing data. Training data is everything that you push to the machine learning algorithm so that it learns, so that it uses it to understand what is going on. Next, to verify if the machine has learned anything or not, you are going to use another set of data which the machine has never seen before to eventually go on to see if it has learned something, if it can do things in the correct way or not. So training data is used to train, testing data is used to verify if it has learned or not. So usually in the common usage, data is split into 70% of training data, 30% of testing data, or 80% of training data, 20% of testing. There's a very good balance here in a way where majority of the data gets to the training, because more the data the machine can train better. And of course, you can get away with a small amount of testing data to verify if it has learned something or not. But then again, this depends on the type of solution, the type of algorithm, the type of learning that eventually has gone into usage, right? It's not always the case where, if you just use 70% of training data and 30% of testing data, that you will get the correct solution. This is open to experimentation. Sometimes you'll use 70 on the same data set. If you go on to use 85% of training data, it will give you an exponentially better solution, because it might have learned something new in that aspect of data which you had given it before, right? So it's very important. Now, coming to the analogy, this is literally like how you would write an examination in school or college, right? First of all, you would have been given a textbook or any other study material where you're going to use it to learn nicely. And after that, there's going to be an examination where people are trying to evaluate. They're trying to verify if you've learned something or not. Well, training data, testing data, exactly the same thing, right? Now, I hope you have complete picture on the data side of things. But to talk about the entire life cycle of machine learning, right? Well, here it is. Whenever you are solving any problem, be it a real life problem, a hypothetical problem, whatever it is, what is the first thing? The first thing you have to understand is that there is a problem that you have which you know machine learning can be used to solve it. The next thing is you understand the problem itself in a way where your thoughts are aligned towards using the domain to solve the problem, right? So once you understand the problem statement, once you understand the business problem completely, then the second step is, okay, so now I understand the problem. Next, I need data to go on to teach my machine learning algorithm and use it to train, right? That is exactly what goes on here as well. After you understand the problem, you start data acquiring, you start gathering data from multiple different places. Data can be stored on your server, on your cloud computing platform. It can be on your pen drive. It can be social media data. It can be competitor data. There is no end to bringing in data from any different source of choice, right? So it's very vital that you understand that you can bring in data from multiple ways and eventually use it. Now, the third thing which we already discussed in the module number 1 is data cleaning, right? I have been mentioning so much that data cleaning is very important. If you do not clean your data, if you feed incorrect data, your machine learning algorithm is going to learn things wrong. If I show it a picture of a cat, but if my data that I've given it says it's a dog, your machine learning algorithm is going to say, hey, it's a dog. Well, as soon as you look at the image, you're like, okay, that's not a dog, that's a cat. Because you know, right? You've been taught right from your childhood. Your machine learning algorithm, that's not the case. If the data is incorrect, it will definitely lead to a very inaccurate result, which is going to be a huge waste of time. So it's very vital that data is cleaned. Now, once data is cleaned, you can actually hunt into the data even before applying machine learning algorithms to get, a good amount of insight. It's called as EDA, or exploratory data analysis. Exploratory data analysis is very, very, very popular because, again, no matter where you can think of it, right? See, you have data which can give you so much insights. If you're exploring into it and picking out insights out of it, that is literally nothing but exploratory data analysis. Again, it's completely a domain of its own. It's a module of its own. We're going to be discussing it in detail. But for now, you have to understand this, right? You can get a chunk of information, right, without even performing any machine learning operations. But once you go on to have this basic analysis done, you want to delve deeper into teaching your machine learning. That is when you will bring in a machine learning algorithm. We already saw the 3 types of learning. What were they? Supervised learning, unsupervised learning, reinforcement learning. So you're going to use one algorithm or one or more algorithm with this particular type whatever you think is the right for the solution, and eventually you're going to apply the machine learning algorithm on the data. It is eventually going to train and it's ready to be verified. You fit the data, you verify if the machine learning algorithm has learned anything or not. That is the step where I'm saying predict your model accuracy. To see if it's accurate or not, first of all, you have to find what's the correct thing, and eventually, what you predicted would be right. So once you mix and analyze the differences that exist between what you predicted versus what actually is the reality, you will get an accuracy difference. That accuracy difference will eventually tell you how well your model has learned or not. You can repeat step 2 to step 3 again. You can repeat the entire process to make sure your data is better, it is cleaned better, you're using a different test train split. You can do a lot of different things until you get to the last step, right? So once you experiment, you will have different models which will use different sets of accuracy to learn. So you will have this idea. After which, right, the last thing that you will do is deploy the model. When I say deploy the model, it means that I have the solution for the problem ready, and now I'm putting it out there so that I can actually and eventually solve that problem, right? That's the process of model deployment. Maybe it is going on a server where you're trying to implement ML on your website. As I told you, right, Amazon, Netflix. So when they code it in the background, they've done until predict your model accuracy step. After that, as soon as they put it on their website, as soon as things go live, that is when they have deployed it. That is when it is actually working to provide a solution, right? So that is something that you should know about. Right, so guys, this is the entire architecture of how a machine learning model learns and works. I hope I was completely clear on this aspect. Python is the most important programming language we have whenever we're working towards machine learning, right? It is very, very, very vital that you, of course, you can use multiple different languages for machine learning, but you have to find the simplest and the easiest way to do it so you don't break your head about complex syntax, but rather use your time effectively to eventually drive a good solution, right? That is where Python comes into the main picture. Python is a very, very powerful programming. As we have discussed already, it is the most popular language out there. But for machine learning, it is the number one language. It is always preferred no matter what. Why? Because it gives you a high level syntax where you can again spend time on logic rather than the syntax itself. It's very easy to work with. And personally, if you ask me, the biggest reason why it's popular is now when you think about machine learning, if you've never looked at machine learning code, there's a good chance you might think, okay, so if I have to teach my machine, train it and get it one step closer to artificial intelligence, it might take a huge amount of code. Guess what? With Python, that's not the case. A tiny amount of code that you write can have a huge impact, as I'm going to show you practically now. It's a very important thing, right? So you don't have to write 100 lines of code to see a tiny output. You write the tiny line of code to see a huge output. That is the power of which Python adds to this field of machine learning, guys. So that's an important thing. And of course, working with Python is amazing. You have multiple ways. You can install Python from the Python website. You install it via Anaconda. You can have an IDE, an integrated development environment like PyCharm, or you can use a very simple Jupyter notebook on the Google Cloud platform called as Google Collaboratory. Again, all of these are free to use. So eventually at the end of the day, working with it, setting it up and starting to use is easy, as we have already discussed in the previous modules, right? Here are some of the important libraries which you're going to require for machine learning as well. First of all, to store data, to array processing data, manipulate it, and eventually work with complex numerical computations and data manipulation operations, you require NumPy and Pandas. NumPy and Pandas we covered in the last module to a good amount of depth to show you all the operations which you're going to require, right? Again, we're going to use all of these now as well. But then one important library that is very, very important for machine learning is scikit-learn. Scikit-learn is a beautiful library which is meant for machine learning, which is built so that machine learning can be worked around with in a very, very easy fashion. Right, guys. So after this three libraries, again comes data visualization libraries. You have Seaborn, you have Matplotlib. We're going to discuss all of these in the data visualization module in depth again. Right. Now, whenever you're taking a look at the traditional way of how one can go on to program versus how a machine learning algorithm learns, there is a huge difference which you may or may not know. So when you compare traditional programming, how does it differ with machine learning, right? Here it is. It's a very, very important difference. Look at the left of your screen right now. I've put in traditional programming, right? In the case of traditional programming, what usually happens is you have data and you have a program. Your program uses the data, it's a compiler, whatever it is, and eventually gives you a simple output to work with, right? You have input, you have the computer program, input goes into the program, eventually what you get is an output at the end of the day. With machine learning, that is not the case. You have data and your machine learning algorithm already knows what the output is. It will know where it has to get to. It's not like there is no light at the end of the tunnel here. It already knows that, hey, using this data, I have to get to this output. So how can I get from this data to this output is how machine learning works. The entire process of it learning to go from understanding the data to get to the output is where it's called as a machine learning model, right? So every time, we talk about machine learning, it can be very confusing saying, hey, you have an input, you have a program, you get to the output. No, with machine learning, you already have the output and the data in the previous stage itself. And the process is what is, it's what we are after basically when we look on to this domain as well, guys. So there's a very, very important difference, which you should know about if you're looking towards learning machine learning, no matter what level, basic level, intermediate level or advanced level. This is a foundational concept which you guys should know about, right? Now that we looked at a lot of things, it is high time we check it out all practically, right? So here are some of the machine learning algorithms which will add a ton of value to not only your career, but to your entire learning in the field of data science as well. Of course, all the algorithms that I'm about to discuss right now are the most popular ones out there. They are the trending ones for this particular year. People who are hiring, right? Companies who are hiring right now for machine learning jobs or data science jobs will ask in the job description saying, you may or may not know one or two algorithms, but all the algorithms that I'm about to discuss usually are in that list which says it's a compulsory requirement for you to understand. So when the recruiters themselves say that you require these many machine learning algorithms, the knowledge of it, well, it becomes vital that we cover it and teach it for you, right? So here are some of the algorithms that we're going to be discussing, guys. First of all, there are many different algorithms that you can look towards and work with. There's linear regression, logistic regression, again, regression, right? We already discussed this in supervised learning. You have the naive Bayes algorithm, you have the KNN algorithm, you have SVMs, support vector machines, you have random forests, and you have many different types of algorithms, which eventually has its own way, uses its own protocols, uses its own way of learning to eventually get to the result. But to simplify things down and not pick up all complex data sets, let us work one by one into the top machine learning algorithms that you have to learn, guys. We're gonna keep it very simple. We're gonna take a look at simple data sets. I'm gonna explain what each line of code means so that you completely understand, right? So first of all, we have linear regression here. Again, what is regression? To roll back on the same concept we checked out, we are trying to model an input variable by applying a function on it and eventually calling it an output, right? An output is a function of the independent input variable. So when I say input variable, when I say independent variable, it means the same thing. When I apply a function on the independent variable, it becomes a dependent variable on the outside, and that is your eventual y is equal to f of x. Y is the dependent variable, x becomes the independent variable, right? So there's another question which I'm usually asked a lot when I talk about linear regression, no matter where I go, is why is it so popular? Why do I have to know machine learning if I'm if I'm looking towards machine learning or if I'm looking towards data science as well? Well, the first thing that I can tell you, it is extremely popular because it will give you this cause-effect relationship which the real world requires a lot, right? Now, to simplify things, just let's look up at the sky right now if you're sitting outside or something, or maybe just look outside right now. How is the weather? If I ask you a question, what will you do? Right? You look up at the sky, you look at if there are clouds, if it's not cloudy and all of that. If there are black color clouds and you know that there are possibilities of rain, you might get a hailstorm, you might get snow and all of these things, right? If there are a good amount of clouds, right? Of course, weather changes rapidly. That's not the point here. The cause of the rain is what? Clouds. But what is the eventual effect? The effect is rain, right? Clouds cause rain. The effect is rain, the clouds is the cause, right? So that relationship, I just give you one example. You can think of hundreds and hundreds of examples like this. So this is eventually what is, used in today's world as well. That's why it is very popular. So what we are going to do is we're going to head to Google Colab. We're going to practically check out how we can implement a simple linear regression model by using a very popular data set. It is the Boston housing data set, right? Now, with this data set, what we're trying to do is, this consists of all the details of the houses in a locality in Boston. We're trying to see if our machine learning algorithm can predict the prices of the houses based on a multivariable assessment going on. It's called multivariate analysis. We're going to use multiple variables to see eventually to train a machine learning algorithm saying, hey, do you know why the prices are like this and how accurately can you detect these prices? That is the question we are going to get an answer for right now. Alright guys, we are now here at Google Colab. As I told you, free Jupyter Notebook hosted on the Google Cloud platform. You can just type in your Python code, hit the play button and you're done. You do not have to install a lot of these popular libraries that we're going to be working with, right? So again, the first step is to make sure we import all of these all the data sets that we're going to be using for algorithms. Of course, you can do it step by step, but to simplify everything, let me quickly go on to import all of these. There's a simple upload button here. With the upload button, all I have to go on to do is just put in our data sets that we're going to be using. It will upload it one by one, and so that we don't have to do it every single time here, right? Again, let the circles finish. It means that it is uploading. Alright, perfect. So all of my data is now uploaded. Let me zoom in on my screen to the max where you can see all the data. Right. Now guys, with linear regression or any algorithm that we're going to use, the first step is what? We're going to be importing all the libraries that we have to use, right? Look on your screen. We are importing NumPy, we are importing Pandas, we are importing sklearn. NumPy and Pandas, I told you it's going to be very important for machine learning. We are using it right now. Scikit-learn or sklearn as it's called is a very important library for machine learning, right? So after importing the libraries, the next step is to import the data set so that, we have a workable data set that we can work with, right? So here, as you can see, pd.read_csv means pandas, where we're trying to read a CSV file, calling it the housing.csv, where all the data of the Boston housing data set is present. Let me go on to hit play and it prints us a lot of the row and column values that are present, right? It's printing us 5. Let's see if we can print 10. Now, boss1.head, boss1 is of course a variable that we just created. .head is a method. If you do not pass any parameters to it, it's going to only output 5. Now in the bracket, if I put 10 and if I hit execute, it's going to give me the first 10 rows worth of data, right? Now there's so many different things here that are talking about the prices of the house, the crime rate that's present, right? What is the age of the house? So whenever you're trying to find the value of a house, what will you look at? How convenient it is from the nearest supermarkets? How old is the house? What's the tax ratio? How many floors does the house have? What is the area footage? You look at a lot of different things, right? So all of these are, each of these columns that you see here are eventually individual attributes that contribute to the price of a house as well, right? Even crime rate. Crime rate is a very important thing that you look at whenever you're buying a house. You'll see if the area or locality is shady or not. If it is shady, maybe the house is worth a lot less, correct? So that's an important thing here. So all we are trying to do at this point is to import the data set, import the libraries, print the first 10 for your reference, right? The next step after importing the data is to clean the data. Now, to clean the data in this particular data set, all of what we require is numbers, right? For example, look at the age column. If I ask you what your age is, will you say my age is orange, my age is apple? No, that's a nonsensical answer to a question, right? If I ask you your age, I am 100% certain that the answer you're supposed to give me is a number. Now, sometimes it so happens that in the data set, right, it will not be a number, it will be something else, something meaningless. You have to remove all of those, because if you do not, your machine learning algorithm is going to use those nonsensical data entities to learn everything wrong, as I mentioned, right? So the next step we're going to be using a function called as isNA. Is basically a function which says, is it a number? We're going to be basically using this method to see if we have any characters where we have to have numbers, right? NaN stands for not a number. We are trying to find values which are not numbers, in the sense they are characters, string and all of that, right? Thankfully, this is a data set which is already pre-processed and cleaned. So no matter which column you take a look at, all the values are 0. It is saying that, hey, everything here is a number. There is no character or there is no data which can throw your machine learning algorithm off. This is a good thing. The data is clean. It is already pre-processed. The next step of the way is a very simple one where we actually try to split the data, as I mentioned, right? We're going to split it into training and testing. That is exactly what we are doing with these 3 or 4 lines of code. But here I've mentioned that, I want to split it 70% of training, which means that 30% of the data is going to go for testing. How do you know? What do you see on your screen that says it has to be 70% for training, right? Look at this variable which I use for test train split methodology. It says test size is equal to 0.3. Now, when it says test size is equal to 0.3, I'm telling it here, what I want to use for testing later is 30% of the data. 0.3 means 30. So what is the remaining? If you have 30, it's 70, right? That becomes training. What if I put testing data as 20.2? If it is 0.2 or 20%, it means 80% of the data is being gone for training purposes, right? Now, if this is 0.5, it means 50% of the data for training, 50% of the data for testing, right? However, I have found the sweet spot to be somewhere around 70% for training for this data set. So let's check out what goes on. The next thing we're going to do is, since we are checking out linear regression, right? LR equal to linear regression and LR fit equal to X train and Y train. So what we're trying to do here is we're trying to model, get the model to understand the data that we have been checking out in terms of the training data. Now, if you were a person who thought you required 100 lines of code to train a machine learning algorithm, you have 3 important lines where the machine learning algorithm actually does the learning process, right? The model fitting, when you say fitting the model, it means to actually use the data to learn. And later you're going to be predicting it based on the testing values which I mentioned. As you can look at it, the parameter we send for predictions is also the testing data set rather than the training data set, right? If you just send the training data set again, what happens is that it already has seen the data. It will tell you 100% accuracy because it knows everything that it is seeing. If I give you a textbook and if I ask you, hey, write an examination based on this, where there are direct answers in the textbook, you do not have to spend a lot of time to learn it. It doesn't make sense. You can get 100 out of 100, right? But if I give you something else where you have to use your processing power to do it, that is exactly what we're trying to do. So with these 3 or 4 lines of code, our linear regression algorithm has learned everything it has to learn. Next, we have to see if it has learned or not. That is where we use error rates to actually go on to see if it has learned something. Now, there's an error rate called as MSE or mean square error, which is again a concept of its own, which we are going to use to predict if the machine learning algorithm has learned anything or not. So let's see what error we get here, right? So it will be somewhere around 5-ish. Okay, yeah. The error that we see for using linear regression is 5.54. Now, if you are wondering about what this number means, hold this number in your thought for a second, because we're going to use the same data set for another algorithm. That way you will understand what happens if you use the exact same data but 2 different machine learning algorithms, right? Which one learns more accurately? Again, we're going to be checking this data set out, in the next machine learning algorithm that we will discuss. Of course, not the exact next one. We're going to be checking out the third one. But now, moving to the second machine learning algorithm that we're going to be checking out is naive Bayes algorithm. Naive Bayes algorithm is a very, very popular algorithm that is, again, not just popular just because how it works, but rather the usefulness of naive Bayes as well, guys. Now, naive Bayes is an algorithm which works based on the Bayes theorem. Now, Bayes theorem is completely based upon the concepts of conditional probability, right? Conditional probability talks about the probability of one event occurring if another event has already occurred, right? P of event 1 occurring given that P of E2 has already occurred. That is Bayes' theorem. So naive Bayes uses the concepts of conditional probability to work. It is again a type of supervised learning, just like how linear regression was. And here it is called naive because there is no codependency in between these attributes. So each attribute does not use itself or use the other one to get to the output. So since you don't have the dependency, it's more like a loner entity which sort of learns to, which sort of tends to not learn efficiently. But it's not efficiency, but it's the way it learns. That's why it's called as naive in real life, guys. Again, it's a funny way to name it, but yeah, it does work. And now it is very, very popular for two important things: is social media marketing and product management. So whenever you have a supply chain analytics problem, or whenever you're trying to market something on social media, you want to analyze the impact of your marketing, right? Naive Bayes is very, very, very popular in those cases. Again, there's many types of naive Bayes algorithms that we're going to be checking out. There's the multinomial naive Bayes, there's Bernoulli's, there's Gaussian. We're going to pick up one of these to make sure that you understand naive Bayes in detail. Of course, to do that, we are going to be using the social network data set, guys. So let's quickly get back to our Google Colab. Let me minimize linear regression and check out machine learning with naive Bayes algorithm, right? Perfect. Again, guys, what is the first step whenever we go on to work with anything? We import all the libraries, NumPy, Pandas, and scikit-learn, right? As soon as I click play, all of the libraries are done. The next thing is we're going to be importing the data set. In this data set, right, the salary data that we're going to be working with now, I have already pre-processed into training data and testing data separately myself. So I do not want the machine learning algorithm to again split it. Of course, I can manually define and get it to read and input two files. Salary data underscore train is the training data set. Salary data underscore test is the testing data set, right? So as soon as I go to hit play, let us check out what the data set itself is. So here, there are a lot of different columns of how the data is working with, right? So whenever you're looking at salary data, we're trying to see what adds the most value to the salary, right? The working class of the person, the age of the person, education, marital status, occupation, relationship, the race, the sex, the capital gain that they're holding. Does that have an impact on having a high salary? So what value, what attribute here adds a lot of value to eventually having a high salary is what we're going to check out, right? So as you can see, we're trying to check out all the education that the person has and the eventual salary that the person might have. What is the salary range that they're getting? Which country are they native of? How many hours per week they work? So all these data we're going to be using to teach the machine learning algorithm, right? So to go on to use naive Bayes, the next thing we're going to be using is a concept called as a label encoder. Now, all of these values that you see, right? Relationship, not and family, husband, white, male, female, married, spouse. All of these are what type of data? Categorical type of data, right? But to make sure our machine will not understand husband, wife, and all of that unless you teach it, right? To simplify all of these things, we're going to convert every single categorical variable we have into a numerical data, and just to do that, we're going to use something called as a label encoder. That's the entire process. All we're trying to do is convert categorical data into numerical data here. Once that is done, all of these get encoded into a numerical data format. It becomes variables of its own. Then we actually go on to assign it testing phases and training phases. That is literally what we're doing. 13th column is the last column for salary, right? So we're trying to add these encoded variables and assign them, saying, hey, what is your impact on the salary, right? As I told you, there's three types of naive Bayes classifiers that we're going to be, that we actually have, which you can use depending on your application. Here we're using Gaussian naive Bayes. Gaussian naive Bayes is mostly used for continuous data, right? Now the data is continuous here. Salary is a continuous thing which will change based on your experience, right? The first salary which you might have got after graduation is very different from the salary you have after 10 years of experience. It's a continuous graph that rises up and up. So if the data is continuous like this, you're going to be using Gaussian naive Bayes. But if your data is, let's say, binary data, if you want answers such as yes or no, true or false, up and down, all of these answers, which there are only two possibilities, binary outcomes, you're going to be using the Bernoulli's naive Bayes classifiers. And there's another one which is called as multinomial naive Bayes. Multinomial naive Bayes is extremely popular for text classification, speech recognition, all of these things. We're not doing any sort of speech recognition here, nor are we having a binary outcome, right? Hence, the reason we're going to be using Gaussian naive Bayes. Now, as you can see, as soon as I ran one line of code, model fitting is actually done. The next thing all I have to do is predict by passing it the testing data to see if it has learned something or not. And since that is done in 2 lines of code, the next thing I'm going to go on to do is print a confusion matrix. Guys, a confusion matrix is a very important concept which we already checked out in statistics, right? True positive, true negative, false positive. All of these values, as you can see on your screen, the most concerning numbers will be the true positive values and the false negative values. These has to be the highest because at the end of the day, if these are the highest, it means your model has learned really well. We do not want false positives, or we do not want false negatives, because these are sort of the values which your machine predicted wrong based on all the values out there, right? Now, if you do not understand confusion matrix, again, I have an accuracy metric here at the bottom which says, hey, I have an 80% accuracy rate of detecting things correctly and making sure it matches up to what we predicted at the start as well. So for every 100 elements of data it sees, it can predict 79 or 80 of it perfectly. That is what our machine learning algorithm is trying to say to us, guys. Right, that was naive bias. Next, we're going to take a look at the KNN algorithm. KNN algorithm has a full form. It's an abbreviation. It stands for K nearest neighbor algorithm, right? Now, let me give you an example to explain what KNN algorithm means or how it works. Let's say you want to visit your friend's place, who stays nearby to you. Is there only one road ever that you can take to get to your friend's place? There's a good chance that you can take very inefficient routes to eventually get to his house. You can take one route, two route, another crossroad, whatever it is, right? If your friend stays in the next street, the most inefficient way to go to his house is probably fly to America and fly back and directly go to his house, right? That's a possibility. It is stupid, it is meaningless, I understand, but it is a probability still, right? You cannot say it's stupid in the case of machine learning because it does not understand that it is stupid. You have to teach it that, correct? So here what we're trying to do is we have certain data. As soon as we put new data there, we try to index it based upon whatever data points are nearby to it. And from then we map an association saying, okay, so it is closest to this data. It may be the same data or similar data as well, right? So again, that's a very important thing. KNN algorithms are a type of lazy learners. It means they do not really take a lot of time to execute. They do not want a lot of computing power to go on to learn and execute as well. But then to go on to practically check it out, first let me give you a theoretical example to make sure you understand these things properly, right? Now, what we're going to actually do is we're going to try to predict if the person is a male or a female based on their height and weight. Now, it's usually a common survey or a statistic saying that, male or guys weigh more and they are usually taller than the female population. Of course, it might not be the case in every single country or every single place, but the usual statistic is somewhere like this, right? Guys are taller and they are heavier in the build because that's how human bodies eventually work. In that particular case, can we predict if we just have height or weight of a person to see if they are male or female? Well, here are some of the things. I have heights of, these many people, 7 people. I have weights of 7 different people. And eventually I have the gender also, that if you have this height and weight, that person is a male. Now, this is accurate data. This is the data that I've collected from 7 or 8 different people. Now, if I have to teach my machine learning algorithm using KNN, saying, can it predict if it's a male or a female? Here's a graph. This graph is very simple. You remember seeing this chart, right? This chart with just its height and weight in the X and Y axis. We have just put the data out there. As you can see, we had 7 data points, right? 3 of the data points are female, as you can see in the pink rectangle, in the pink triangles. Then 4 male data we had based on the green circles you see on your screen right now. As soon as you look at it, you can sort of say that height and weight of the females are slightly less compared to the height and of course the weight of the male population in this example, right? Now, what I will do is, there are 7 people here. I'm going to add another 8th person. I'm not going to tell if it's a male or a female. I just know that this person has a height of 190 centimeters and a weight of 100 kilos. If I put it and map it in the graph, the blue color rectangle you see right now is where that person will be put if the weight and height are matched with what everything else is put, right? Again, you as a person can look at this graph and say, okay, this new person added here is very similar to the guy's weight and height, so that he might be a guy, right? If it was somewhere here, you would see that there's a good chance it's a girl. But for our machine learning algorithm to do it, we have the value of K. K is us saying that, use the 3 nearest neighbors to map a pathway to the new person who was added. If K is equal to 3, as you can see, these 3 green dots are the nearest neighbors to this particular rectangle, to the new data, right? So if K is equal to 3 and if all 3 are pointing to the same guy and all the 3 closest points are guys, Your machine learning algorithm can say, hey, I have a 90%, 95% accuracy of saying that the new person you added is a guy. That is how it learns, right? Now let's put k equal to 5. If we put k equal to 5, you're finding out the 5 nearest neighbors, right? 4 of them are guys, 1 is a female here. Now, 4 of them are guys, but 1 is a female. Can it still say it's a female? No, right? Why? Because the majority of the neighbors are still male population, right? So that is how we accurately say, hey, the data we have here, the new person you added is a male, right? Now, if you've been seeing, I took k equal to 3, I took k equal to 5, both are odd numbers. Why did I only pick odd numbers? Well, you can use even numbers also, but the general way of working in the KNN algorithm is that if you pick the k value as an odd number, the number of neighbors that you have to track and index, you will use it as an odd number if you only have 2 classes in comparison, right? Here we only have 2 classes, male and female. That's it, right? We're only considering these 2 populations for this example. So since it is only 2 classes, it is vital that we go on to use this value, which is, an odd number, guys, right? The next thing we're going to check out is, again, as I told you, right, we're going to be checking the same Boston data housing data set. With linear regression, we got an error rate of somewhere around 5.4 or 5.5. But what is the error rate we're going to get if we use KNN algorithm, right? So let me quickly minimize the naive Bayes algorithm and let me open up KNN algorithm. Perfect. So again, this code is the exact same thing that we checked out while we were working out with linear regression. All we try to do is import the data set, import the data, import the libraries, print out the first 5. Next, we're going to be removing all the NAN values. As I told you, the data is already clean. Again, this was the exact same thing that we checked out. We're going to be splitting the data into 70-30. We checked out the exact piece of code. But the next thing is what we didn't check out is where we are trying to load the KNN model and use it, right? These 4 or 3 lines of code that you see is where we're actually going to use the KNN algorithm, right? So again, 3 lines of code. But if you see in the bracket here, I put a parameter 3 for KNN regressor, right? This is me telling the machine learning algorithm, hey, use k equal to 3, right? As I showed you, as soon as I run this again, it's going to use the training data to learn. It's going to use the testing data to see if it has learned and all of that. 3 lines of code. Now, the next thing is, how do I know for sure that for the Boston housing data set that k equal to 3 is the most accurate value? K equal to 10 may give me better solutions, right? To make sure that I'm tuning all of these values and tweaking it to get my model to learn accurately, I'm going to do hyperparameter tuning. In hyperparameter tuning, what happens here is that I just since it's a small data set, I can just get the machine learning algorithm to work for multiple k values, which is exactly what I've done here. I've got the k value from 1 to 49 to see where the k value is, the error is the lowest, right? So k equal to 3 is what I said will be the lowest. It's 7.01. But hey, check out k equal to 4. K equal to 4 has an even lower error rate. So what it's trying to tell me is, for this data set, for the Boston housing data set with this algorithm, you will get the most accurate output. You will get a lesser error rate if you use k equal to 4. I wouldn't know this until I did it, right? Hence the eventual purpose of mapping out all the k values out here, guys. And of course, the last step is for us to always print the mean squared error. In this case, the mean squared error is 7.014 for k equal to 3, correct? It was 5.5 for linear regression. For the exact same data set, it is 7.01 here. What does that mean? It means that our machine learning algorithm for that particular Boston housing data learned better in the case of linear regression rather than using KNN on that data set, right? Now, once you use multiple algorithms, this is the clarity that you get, which is a beautiful thing. So, right, guys, next up, we're going to check out support vector machines. Support vector machines are very complex entities in the world of machine learning because here the way that they learn itself is very, very different. They use multiple unknown parameters and they use a technique which is called as a black box techniques because there are so many unknown parameters, so many things going on in the background that it uses to learn, right? But then there are certain basic things that it has to work with is linear data and non-linear data. So in the case of non-linear data, since it is very difficult to train, it actually separates this data by making use of something called as kernel tricks. And all of these parameters which eventually come after kernel tricking is usually tested and tuned by making use of kernel functions. Now, there are multiple kernels that we can use as the polynomial kernel and the RBF kernel, the radius basis function kernel. kernel. Each kernel has its own way of working, right? So what happens with the polynomial kernel is that with the polynomial kernel, the data gets transformed into a higher dimension and eventually it works into its nonlinear classes. But with the case of radial basis function, the RBF kernel, here we have a parameter called as gamma, and we continuously tune this parameter rather than changing any dimensions, which eventually gets us to our results. That is how we're going to be using SVM, guys. So until we keep scaling these gamma values, RBF will go on to give us different outputs, and we find the best one and we usually hold it there, right? Now, coming to the advantages of SVMs, the most important thing is that it is very, very flexible to work with a variety of data, be it unstructured data, structured data, semi-structured data, whatever it is, right? Unstructured data is images, music, videos, and all of that. Structured data is everything that we checked out, right? A nice CSV file with rows and columns worth of data. Semi-structured data, there's again multiple types of data based on the usage as well. So one advantage with SVMs you have to understand is that overfitting is not present, or it's very less here compared to all of the other models out there. So overfitting is a situation where your machine learning algorithm is learning so deeply with so much focus that it starts picking up noise in the data rather than useful stuff. So using its noise, it will not learn anything at the end of the day which is accurate, right? The data is going to be completely inaccurate because it hunted so deep into the data, it found noise rather than useful information. That is overfitting. In the case of SVMs, overfitting is less. But to talk about the disadvantage of SVM as well, one thing is that the training time will be a lot more if your data is huge. All the data sets we've been using now are very tiny figments of data, so it's working beautifully well. There are some cases where your machine learning algorithm can train for hours together, if not days together as well, if you use SVMs, right? The reason why SVMs are popular today is because they have a huge impact in the world of healthcare and in the case of banking sectors as well, guys. So it's a very popular thing. Let's actually check it out practically now. Let me just minimize KNN. Perfect. Let me open up SVM. And what's the first step in SVM or any algorithm? I can zoom in a little more. Perfect. Is to import all the libraries, importing NumPy, importing pandas. Now here I have another library called matplotlib. Matplotlib is used for data visualization to create beautiful looking graphs, right? Done. The next thing is to import the data set. Here we're going to be using the social network advertisement data set. So what we're trying to do is, if you advertise something, right? If you're advertising a pen or a pencil, and you know the salary of the people who may or may not buy the product, right? What is the probability that a person will buy the product if their salary is somewhere around that, right? So using salary to see if a person of this salary can afford your product or not. Now, if there's a very expensive car like a Ferrari or a Rolls Royce, there's a good chance the common man cannot be able to afford it, right? So advertising that to a common man might be considered as a waste of money as well. So to check if the person of this salary band can afford a product like that is what we're going to try it out. But with this data set, as you can see, we have a user ID, we have the gender and age, estimated salary and purchase. Now, what are we concerned about? We're using the salary to see if a person purchased or not. So we do not require the age. We do not care about if a male bought it, female bought it, or whatever it is. So we can drop all of these columns, user ID, gender, age. I do not want. I just want salary and purchase, right? So I'm going to filter all of these columns out with just 2 lines of data. The next thing, again, we're going to be splitting the data. This time, not 70-30, but 75-25. 75% goes for training, 25% goes for testing, right? As soon as I click this, that is exactly what I did. Now the data is split up. Next, we're going to be using a scalar called as a standard scalar for normal distribution. The normal distribution is a bell curve, which will add meaning to the data so that we can plot it and derive some meaning out of it, right? So by using a standard scalar, all we're trying to do is we're trying to use the training data, map it and verify it against the testing data by using normal distribution. Again, distributions are a very important part of statistics, the concept which governs the world of data science, guys, right? Next, as I told you, there's polynomial kernel and there's RBF kernel. In this particular case, we're going to be making use of the RBF kernel, 3 lines of code. Your model, the SVM has learned it completely. And at the end of it, if you're trying to print the confusion matrix, again, confusion matrix, we discussed this in the last module, true positive, true negative, false positive, and false negative, right? So again, I didn't see it in order. There's an order of which the values goes on. You guys are supposed to tell me the order because we covered it in detail. The values I am concerned with are 64 and 29, that they're high. That's perfect. We have 4 and 3, which the model got incorrect or it predicted in the wrong way, which is absolutely okay. Again, here is where statistics come into the picture, right? You remember we calculated precision, recall, F1 score and all of that. Guess what? We calculated it here again. Of course, we're not doing it manually anymore. We have classification report which will give us all the details. So we have the precision value if the person bought the product, the recall value if the person bought the product or not. We have the precision, recall and F1 score if the person actually bought the value. 0 means the person didn't buy it. 1 means our prediction based on if the person actually bought it, right? Pretty simple when you look at it, but it's a beautiful concept of how support vector machines work. Right, guys. Next up, coming to the random forest algorithm. Random forest. When you say forest, what is the first thing that comes into your mind? It's a group of trees. It's a collection of trees, right? Here also it's a collection of trees, but not just trees. It is decision trees. Hence, once you have multiple decision trees, you just call it a forest. In this case, it's called as a random forest algorithm as well, right? One thing you have to know about these decision trees is that they have very high variance and very low bias. This is the exact opposite of what we need. We need low variance in our data and very high bias of learning, correct? To make sure that we solve this problem, we just group all of these trees and create a forest. That is how we solve this problem of decision trees having very high variance and very low bias. So what we do here is we take in data just like a real tree. A tree is going to have branches. It's going to have multiple branches. It's going to have leaves, right? So one important node will be our input. From there, we create all our branches, and every single leaf at the end of the day, or the end nodes, are called as leaves. They will be the output in this case, guys. That's why the name random forest algorithm. So how do you go on to pick data when you're working with random forests, right? If you are considering two samples here that we've represented by, two colors, the red and the blue color that you can see, we have multiple columns, right? In the concept that we have called bagging, we compulsorily pick data from all the columns out there to train the machine learning algorithm and to teach it. As you can see, all the pink ones, everything is picked, blue ones, all the columns are picked. But in the case of random forest, what happens is that we do not pick up all the columns. We just randomly pick up, a couple of columns to actually go on to build decision trees and eventually get our, model to learn, right? So that is exactly what we are going to check out here. The advantage of random forest algorithm is that it works amazingly well for classification problems and regression problems, which we already checked out. But if your data is not clean, and if you're a person who doesn't like to clean data, again, it's a very hectic task. Guess what? With random forest algorithm, sometimes if your data has missing values, random forest algorithm has the capability to automate it and fill it with zeros, ones, or whatever it is that it thinks will not hurt for learning. So it can automate itself, learn and fill in data wherever it is missing automatically too. But then one disadvantage of random forest here is that it will require a lot of computation power if you are looking to build very, very, very complex trees and forests, guys. So that's an important thing that you should know about, right? So let's quickly check it out practically now. So with random forest, again, the first step is pretty simple. Import the libraries, import the data set, print the first 5 elements of the data set, right? Now, let me actually go on to print 10 instead of the first 5 because I want to show you something here. Right, now that you see the data, I have 3 tabs here, 3 columns: position, level and salary, which I think is self-explanatory, right? A junior consultant is a level 2 employee who gets an average salary somewhere around 50,000 rupees. A CEO is a person who's a level 10 employee, the maximum level you can obtain, and he gets a salary of somewhere around 10 lakhs per annum, per month, whatever basis, right? We're not concerned about the duration of this particular salary. But look at the growth with the level. A person who's a business analyst is a level 1, junior consultant level 2, senior consultant level 3, manager 4, country manager 5, region manager 6, senior partner 8, 9, 10. Right? So what I will try to predict is the average salary of a person who has the level of somewhere around 6 or 6.5 based on all these data. Again, to do this, I only require 2 columns, level and salary. I do not require position, right? So I'm just going to remove the position column, use only the level and the salary here. Here, I'm going to be using 10 different trees. As I told you, a random forest is based upon multiple trees. Here, I'm going to be using 10 different trees. N estimator is equal to 10 mean means that I want 10 trees to create one forest, right? As soon as I go on to click this, the model has actually learned the creation of the forest is done. So the next thing we're going to do is predict the salary of a person who has level greater than 6.5. So instead of just telling you that in a verbal way or to show it to you in a number, I want to show it to you in a graph. Now here is a very beautiful visualization, guys. What is as you can see, the salary, I have it on the y-axis, the position, I have it on the x-axis. The position we're trying to find is 6.5. So it might be somewhere here, right? Now, if I go to the left of that point, the salary is somewhere around 0.2. Hey, the salary we were checking out was in the thousands. What is this 0.2? Look at the legend on the top. It says 1E6. 1E6 literally means multiply that number, whatever you get on your salary, by 10 lakhs. 0.2 into 10 lakhs is what? 2 lakhs? 2 lakhs for a person who has an average salary of 6.5. Let's take a look. See, for a person who has a salary between 6 and 7, the average salary can be considered as 2 lakhs as well. This is what our machine learning algorithm learnt and predicted for us. So when you have a result in a graph like this, which is very nice to look at, it adds a lot of value to your learning, guys. So this was the top 5 machine learning algorithms that you have to learn. So alright guys, to summarize everything we've learned on this particular video, basically we started out by taking an introduction to understanding machine learning. Right from the foundations, we worked our way up to understand and analyze the entire process of how machine learning works, how algorithms work, and eventually what are the various ways we could teach machines to learn, right? So eventually, once you figured all of that out, you guys were very curious to figure out what are the various algorithms that are out there. We took a look at some of the top algorithms such as KNN, linear regression, random forest, and a lot more, right? So we discussed the theoretical aspects of it. We discussed the practical aspects of it as well. So with this, I hope all of you all are clear with all the concepts that was discussed here. So on that note, thank you so much for watching. My name is Anirudh, and I'll see you in the next one.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.